This is Unit 5, Lesson 4, Applying Transformations. And in this lesson, we are going to be taking the function notation that we learned for transformations, and we're going to be working through several different transformations. So to start that off, let's look at a different way we can express the transformations. So let's start out with translations. We learned that translations can be written as x plus h and then y plus k. H tells us the horizontal shift and k shows us the vertical shift. So that's the notation for translations, and maybe we were told that we are going to take point P at 3, 7, and we were going to translate it using translation t at x minus 2, y plus 4. Now we're going to be doing that a little bit different. So this t signifies that I'm doing a translation rather than a reflection or rotation. And then we're going to take these vertical shift and horizontal shift numbers, this -2 and +4, and we're going to write them just down here as the subscript. Then we'll take point P, which was 3, 7, and put it up here. So now I'm given all of my information right in this spot. I know I'm doing a translation because it's t. I know that I'm going to be going down 2 and to the right 4, and then I know that this is the point that's going to be translated. So moving forward, I can do x and then my h value. So we got 3 minus 2, and then y, and then my k value is 4. So we have 7 plus 4. And I find out that the new translated point is at 111. So this little marking right here told me exactly what I was supposed to be doing and how I was supposed to do it. I'm going a little backwards here. Now that we've looked at an example, let's go through what those specific markings are for translation, reflection, and rotation. So starting with translation, it's represented with a capital T, and then the numbers that we have in the subscript right next to T are the vertical and horizontal translation. The point that we have, or the coordinates that we have right here, is what is being moved. So when we put it all together, we have x plus h and then y plus k. Now let's look at the rules for reflection. So a reflection can be done in two different ways. It can be done in other ways, but we're only going to do it in these two ways. Either a reflection over the x-axis or a reflection over the y-axis. Either way, we're going to represent it with a lowercase r. And then in the subscript, we're going to say where it's reflecting. So if it was an x-axis reflection, we would have r, and then the subscript x-axis. xy represents the point that we are reflecting. If you look back in your notes from a few days ago, we already know that a reflection over the x-axis changes by keeping the same x value and then switching the sign of the y value. Y-axis will be very similar. We have a lowercase r, y-axis in the subscript, and then for this one, when we reflect over the y-axis, the x value switches signs and the y value stays the same. Now finally, let's look at rotations. We're going to look at 3 different types of rotations, just like we did before: a 90-degree rotation, a 180-degree rotation, and then a 270-degree rotation. which is the same thing as 90 degrees counterclockwise. We just called it 90 degrees before. A rotation is going to be represented with a capital R, and then the amount of degrees is going to be in the subscript. So a rotation of 90 degrees will look like this. XY represents my point, and then we already know from last week that when you rotate 90 degrees, the X and Y switch places and the Y also switches signs. Rotation of 180 degrees looks similar. We have capital R, 180 in the subscript, and then for this one, the X and the Y value both switch their signs. And then a 270 degree rotation, or a rotation that's 90 degrees counterclockwise, starts with R of 270, and then we switch X and Y. Y is going to stay positive or negative, whatever it is. X is going to switch signs. So let's take these 6 different rules and 6 different notations and apply them to some examples. So our first example, we're going to take the translation of 2, 3. So horizontal shift of 2, vertical shift of 3. And we're going to apply that translation on the triangle ABC with the points A at 1, 1, B at location 3, 5, and C at location 5, 1. You could plot these points on a graph. You don't have to. Let's do this one without a graphical representation. So first I'm going to start out by translating point A. So I'll do a translation of 2, 3 on point A, which, remember, we instead of writing A, we can replace that with the actual coordinate of A. So 1, 1. This 2 is our vertical shift, and it goes with the first one, our X value. This 3 is the horizontal shift, and it goes with the second one, or our Y value. So when I write this out, I'm going to have X value is 1, plus my shift was 2. My Y value is 1, plus my shift was 3. So my new coordinate for A is 3, 4. Now let's find the new coordinate. We'll use a different color. Let's find the new coordinate for B. So we're doing the transformation of 2, 3 on point B. Well, remember that point B, up here we see has the coordinate of 3, 5. So when I follow the notation from back on this previous screen, right here, for translations, I can do X, which was 3, plus H, or my vertical shift, which was 2, Y, which was 5, plus my horizontal shift. I hope I said those backwards, I'm sorry. X plus H is the horizontal shift, Y plus K is the vertical shift. So we end up with our new point at 5, 8. And now finally we need to do our translation of point C. So we do X value plus H, Y value plus K. Here's my H, here's my K. X, Y. And we end up with 7, 4. So you could go ahead and you could plot these points on a graph and see that it is the same shape. It is congruent. They are still triangles. We've just taken that triangle and we've shifted it and moved it to a new place. The second example is a 90-degree rotation, which we can see from our notation right here, capital R and then 90. And we're rotating triangle ABC again. This time A has a point at 1, 4, B at 6, 3, and C at the location 3, 1. So let's start off with rotating point A 90 degrees. Well, point A is at 1, 4. And then if you look back to where we wrote down all of our notations, we know that a rotation of 90 degrees around the point XY means that we switch X and Y becomes negative or positive, it switches signs. So my X and Y, the 1 and 4, are going to flip places. And then the Y value, which was 4, is now going to switch signs. So it's going to become a negative 4. Now let's do it for B. Rotation of 90 degrees around point B means that we are going to be rotating the point 6,3 90 degrees. Rotation of 90 means that X and Y switch places and the Y value switches signs. So if my Y value starts out as 3, it's now going to be negative 3. If the X value started as at 6, it's going to now be at the back of positive 6. And our final point, our rotation of 90 degrees at point C, which is a rotation of 90 at the location of 3, 1, because C is at 3, 1. So X and Y switch places, Y switches its sign. So we have these 3 new coordinates for our new triangle. Now, it's important to make a note here that we've switched X and Y, but we haven't switched the way that you plot the point. That's just kind of like up here. This thing is kind of like the trick to help you complete the process. When it comes to actually plotting the points, I still go x-axis first, then y-axis. Still go horizontal, then vertical. X, Y. This is still the x-axis, this is still the y-axis. So if I plot these points, oops, we're going to run out of room here. Negative 4, 1, I'll still go back 1, 2, 3, 4, and then up 1 to plot my point right here. Negative 3, 6, I'll still go back to 3, and then up to 6. Negative 1, 3, I'll still go back to 1, and then up to 3. We still plot using the same XY process that we've learned a long time ago. So go ahead and pause the video here, and I want to go through your first example or your first problem on your assignment together, because this is one of those compounded examples where we have 2 transformations that we're going to be putting together. So pause it here and get the assignment passed out, and then everybody get ready to do number 1. So you should all be looking at example number 1 on your worksheet right now. This worksheet is Unit 5, Lesson 4, and it says defining and applying rotations, reflections, and translations. Notice it also says to do problems 1 through 5 and 7 through 9, so you don't have to do 6 and 10. Okay, so this one's a little tricky because we are given the transformation 2, negative 3, and we're also given the transformation of 2, 5. This is what we mentioned a few days ago. I believe it was last Wednesday maybe. When you have 2 transformations, remember you always go inside out. So we're starting with the innermost translation first, which is the translation of 2, 5. So I'm going to start with translating 2, 5, the point A, which is at the location 1, 2. So x is 1 plus h, y is 2 plus k. So we find our new point, or A prime, is at 1 plus 2 is 3. 2 plus 5 is 7. Our new point is at 3, 7. Now we need to do the same translation for point B. So point B is at the location 2, 7. And I'm going to do x plus h, y plus k. My new point, or B prime, is at 2 plus 2 is 4, 7 plus 5 is 12. And now I need to do the same thing for point C. So everybody go ahead and do the same thing right now for point C. I want you to do this on your own, and then when you're done you can go ahead and check, look up at my answer and see if I got the same thing that you got. So I have these 3 new points. I have A prime that's at the point 3, 7, B prime that's at the point 4, 12, and C prime that's at the point 6, 6. That's only with me doing my first translation. I'm working inside out, so now that I've done the inside translation, I need to move on and do the outside translation. So let's clear this stuff from our screen. And let's move on to our second translation. The second translation is 2, -3. And instead of translating point A, I'm now moving point A prime. And remember, point A prime, we've got listed up here. A prime is at 3, 7. Let's make that -3 a little smaller. So I can take my x value plus my horizontal shift, my y value plus or minus my vertical shift, and my A double prime, because this is the second position for point A, is 5, 4. Now let's do that for B. Remember, it's not B that we're moving, but it's B prime that we're going to be moving. And B prime is at 2, 7. So my x value plus my horizontal shift, y value minus my vertical shift, and if I was at class right now, you all hopefully would be yelling at me right now. If you don't know what I've done wrong, I want you to take a look at this and see if you can find what mistake I've made. Hopefully you realized that I used B. I used the point 2, 7 rather than using the point B prime. So let's go back and fix that really fast. We need to make sure we are using B prime. So we're using 4, 12, not the point 2, 7. So we have x plus 2, y minus 3, and B double prime is at the point 6, 9. We have one more left that we have to do to finish these two translations. So I'm going to go ahead and do C prime. And I want you all to do it in your notebooks as well, or in your assignment as well. So C prime was 6, 6. I have my translation of 2, negative 3. Let's make sure that shows up as a negative 3. So we end up with 6 plus 2 is at 8. 6 minus 3 is at 3. My final positions are 5, 4, 6, 9, and 8, 3. Remember, always go inside out. Start with your innermost translation and then work your way out to the edges.